Okay, today we are going to be solving linear systems by substitution. So in our previous lesson, we learned how to solve systems by graphing. Okay, so here we solve them by graphing. So you graph the two lines, we look for where they meet. Okay, this is a decent method for solving, but it only finds those solutions that are nice numbers and only works for equations that graph nice. Not all linear equations graph really nice. Some of them are like weird fractions. And the solutions aren't nice whole numbers. And I'm sure you've seen when doing the practice, if your graph gets a little off, then you have a really hard time finding the solution. So we're learning another method. So this is another method of solving these systems. And again, by solving these systems, what we mean by is we're looking for a solution. So find an XY, basically an ordered pair, that works in both equations. Okay. So here's the steps of the method. I broke it down to basically 4 steps. But basically we're going to be substituting, meaning replacing one thing for another. That's what substitute means. So our first step is to solve one equation for one variable. Now, the equation you pick, this step, first of all, isn't always necessary. So this step, you don't always have to do it. Because sometimes one equation is already solved for one variable. And also in this step, some equations are easier to solve for certain variables than the others. So I'm just going to say be careful which equation you choose. And basically what I mean by that is if your problem is in the very first step gets really difficult or a lot of crazy fractions and things, you might want to go back and pick a different equation. And so really the method of solving these is 3 people could solve these and do them 3 different ways. It all depends on which equation you pick and which variable you solve for. Okay, so let's go ahead and let's look at this one we're solving here in task 1. So it says, again, solve one equation for one variable. Well, if we notice these equations, like this very first equation, is already solved for one variable, meaning I have one variable on one side all by itself and the rest over here. So I don't actually have to do this step for this problem because it's already solved. And actually both of them already are because this is already solved for one. And it's okay if both of them are. You just for sure need one equation solved for one of the variables. So for this one, step 1's already done. So here, step 1 already done. Since this equation is solved for y. Okay, you can solve for y, you can solve for x. You just need to solve for solve one of the equations for one variable. It could be x or y. And again, it could be either equation. It just depends on some of them are easier to solve than others. Okay, step 2, here's where the substitution comes in. Substitute what you did from step 1, which we already have in this case. There's what we have from step 1, into the other equation. So there's going to be one you haven't touched yet, into the other equation and solve for the variable. Okay, so what we're going to do is we have this equation solved for y. So we're going to replace the y in this equation with what this y is equal to. So we're replacing this y with an x plus 2. So my new equation, so I'm taking this one, and instead of y equals, I'm using this x plus 2 for that y. X plus 2 equals 3/4 x plus 3. So there is my substitution step. So here's my step 2. So there's my substitution step. And then solve for the variable. Because if you notice now, this equation only has one variable. It only has x's, no more y's. So we can solve for x. Okay, so I'm going to solve that for x. What I'm going to do is I'm going to, right now I'm going to cover up that 4. What would I do if it was just a 3? I would probably subtract this x over to this side. So let's go ahead and let's do that. So let's subtract the x, 1x from both sides. So now these two x's go to 0. So on this side I'm just left with a 2. Now I need to figure out what 3/4 minus, and again, this is a 1x. So basically take 3/4 and subtract 1. If you don't know it, this is the point where we bring in our calculator. We could type in 3/4, subtract 1. This doesn't have any decimals in it, so I don't want decimals. I'm going to start getting pickier and pickier about that. So negative 1/4. So this would be negative 1/4. Oh, I didn't mean to be red. Negative 1/4 x plus 3. Now again, we want to get this x right here by itself. I only have 1x now. So I'm going to subtract this 3 from both sides. 2 minus 3 is negative 1. Now I could take both sides and divide it by that 1/4, but dividing by fractions isn't very nice. If you remember, instead of dividing fractions, something we can do instead is we can multiply both sides by the reciprocal. So I'm going to multiply both sides by negative 4 over 1. So now when I multiply these two, I get positive 1, or just a positive x, equals, multiply over here, I get 4. So I now know my x is 4. So there I'm done with step 2. Substitute what you did from step 1 into the other equation, solve for the variable. Now step 3, substitute this value into one of the equations to solve for the other variable. Because I need both the x and the y. I need an ordered pair. I only have the 4. I still need to figure out what y is. So now for step 3, we'll put that over here. Here for step 3, I need to substitute. I know x equals 4. So I need to plug that back up in here for one of these two equations. You pick which one. Okay, it doesn't matter. Does not matter. This one's got a fraction, so that one's a little messy. So let's go ahead, let's put it in this one. So first I'm going to write down the equation. It's y equals x plus 2. But we know x is 4, so y equals 4 plus 2. So y equals 6. So there my y equals 6. So there's my ordered pair. 4, 6. There's step 3. Step 4, check your solution with both of the original equations. So we kind of already have checked it with this first one. We're not actually going to do any graphing on this one for this one. Oh, maybe we will. No, I think we are going to graph. Sorry, change of plans. So now I need to check it. I'm going to come over here and just write check it over here on the side. So meaning when I put a 6 in for y, does 6 equal 4 plus 2? Yes, it does. That was putting it in this equation. Now we're going to put it in this equation. Does 6 equal 3/4 times 4 plus 3? I don't know about that one, so let's go ahead and let's pull that up. So we want to take 3/4 times 4 plus 3. Yep, is 6. So yes, it did work. Check, it works in both of them. Always check your solution. So there's my solution right there, 4, 6. Now, our previous method of graphing will still work in this case, meaning I could have solved this by graphing. And I just want to, well, let's graph it real quick and we'll see how it relates. So here, this equation is y equals. My slope is 1. Y-intercept is 2. So y-intercept is 2. Slope is 1. Up 1 over 1, up 1 over 1. So it's going to be like this line right here. If I can get it, I'm trying to. Right there. Okay. And then this other one has a slope of 3/4, rise and run, and a y-intercept of 3. So y-intercept of 3, up 3, 1, 2, 3, over 1, 2, 3, 4. There we go. We hit it. Gonna come through. Oh, geez. That's really bad. Undo. Okay. It's gonna come through like that. Okay. Ruler it is. Okay. It's gonna come in like this. Whoop. There we go. And again, we have an intersection point. So they intersect right there, which lo and behold is the point for 6. Okay, so again, this is just two different ways of doing the same type of problem. Okay, we could graph it and get the 0.46, or we could use our substitution method. Okay, in this case, graphing would have worked nice. In some cases, it doesn't. This next one would be hard to graph because first and foremost, it's not y equals mx plus b. Neither of these have the really nice y equals mx plus c. We have x plus 2y, 2x minus y. They're not very nice. So we're going to go ahead and solve these using substitution. So again, solve one equation for one variable. So looking, I need to pick one. How do I know which one to pick? Pick the variables that are all by themselves and nice numbers. So I have two variables by itself. I have an x here and a y here. But this y is negative. Negatives tend to just complicate things a little. This x is not. So I'm going to solve this first equation for this. So when I solve these on my paper, first I start, when I write them down, I write them side by side. So if I'm writing these on my paper, I write them side by side like this. That way I know if I'm dealing with this equation, I write under here. If I'm dealing with this equation, I write under here. It's a way of organizing your work. Okay, so I really suggest you do it that way. So if I'm dealing with this equation, I need to solve it for x. Well, to get this x guy by itself, I need to subtract 2y from both sides. So x would equal, because these add to 0, 3 minus 2y. Okay, so now this is what x equals. X equals this. This is what x is. So I'm now going to come up and I'm going to replace this x with a 3 minus 2y. But again, I have to, it's 2 times x. So I need to take 2 times this. And really, this is probably the most difficult part of the substitution method. Okay, first of all, we're done with step 1. This was step 1 right here. It was solving that first equation for x. Now we're over here to step 2, where we're substituting in and solving. So it's going to be 2 times x. I have to be careful. I can't just write it this way. Because first of all, it looks like 23. This here looks like 23. That looks like a 23. But it's a multiply. But if I just write it like that, it's just 2 times the 3, not times the whole x. You're going to have to use a lot of parentheses. So here is 2. Again, this is replacing my x, 2 times x minus y. Because this actually requires some distribution. So now we distribute that 2 in there. So 2 times 3 is 6. 2 times negative 2 is negative 4. Negative 4y minus y. Now I'm going to rewrite these plus negative 4y plus negative y. Just so I can see my negatives. So I have 6 plus negative 5y equals negative 1. I now need to solve that for y. So I'm going to subtract the 6 from both sides, keeping track of where my equal sign is. 0, negative 5y. Negative 1 minus 6, negative 7. Divide both sides by negative 5. Y equals negative divided by negative is positive, so positive 7/5. So 7/5. That's what y is in this case. So y is 7/5. There are no decimals in the original equation, so I want no decimals here. We're going to go ahead and use a fraction, 7/5. Okay, and now I need to, so there was done with step 2. Now step 3. Okay. I need to substitute this back into one of these 2 equations. It doesn't matter which one. So I'm going to go ahead and sub it back into, I can sub it into this one, sub it into this one, or I can sub it into this one. Any of my previous equations. This one I think is going to be the easiest because it's already solved for x. So I've got x equals 3 minus 2 times y. So x equals 3 minus 2 times y is 7/5. So I just need to take 3 minus 2 times 7/5. Let's grab my calculator. 3 minus 2 times 7/5. I get 0.2. Let's turn that into a fraction, 1/5. So x equals 1/5. So my ordered pair, x comes first, 1/5, 7/5. There's my solution. Now, quick step 4, we need to check it. in both of them, make sure it works. Always check it for the check, always use the original equation. So step 4, always use the original equations. Just in case you made a mistake over here in solving this for x, just in case you made that mistake, always go and use those original equations. So we have x, which is 1/5, plus 2 times 7/5. Does that equal 3? So again, calculator's great tool here. So 1/5 plus 2 times 7/5 does equal 3. Check. That one worked. So now let's try the next one. Calculator's in the way. So 2x, 2 times 1/5, minus y, which is 7/5. Does that equal -1? So 2 times 1/5 minus 7/5 does equal -1. Check, it worked in that one as well. So there we have our solution. You always want to check that.